Students, today's topic is circles. You are aware about the different circular shapes in your real life, such as the angles of your mother's, outer shape of your terrace wall, your eating plate, most relevant example, your eating plate, bread. There are several examples of circles. Today we discuss about some properties of the circles, some specifications in the circles which are useful in class 9 mathematics. Contents of this topic is circles and its related terms. Second is the angles subtended by a card at a point. Third one is perpendicular from the center to a curve. Fourth one is circles through the 3.5 equal cards and their distance from the center. Angles sustained by an arc of a circle. 7 cyclic quadrilaterals and 8 what we compute. So let us start with the first term, circle. Circle, the collection of all the points in plane which are the fixed distance from a fixed point in the plane is called circle. See here, this is a fixed point and these are points collected which are equal distance from the fixed point. And collection of these all points are known as circle. This fixed point is known as radius. This fixed point is known as center, and distance from P to fixed point, any point on the circle to the fixed point is known as radius. Now radius, diameter, center, chord, arc and sector. The line segment joining the center and any point on the circle also called a radius. इसके लिए आप पीछे आइए. This is the radius. Next one is diameter. It is 2 times the radius. When radius is increased from one point in a straight line to center in another point of the circle, this becomes diameter. And this one is a line from 2 points drawn from one point of a circle to another point of a circle is known as chord, but this should not be go to the center. If this chord goes to the center, this becomes diameter. If we take 2 points P and Q on a circle, then the line segment PQ is called a chord of the circle. A piece of circle between 2 points is called an arc. A piece of a circle between 2 points called an arc. Suppose that this is one part, this is another part. This is arc, this is another arc. This is minor arc, this is major arc. Then this means a chord divides circles in 2 parts. One part is known as minor arc, another part is known as major arc. And complete region of the circle between 2 parts is known as sectors. Now we take a line segment PQ and a point R on the containing PQ, join PR and QR. Here is P, R and Q. There are 3 points. When we are joining P, R, Q, you can say this is a triangle. This is a triangle. POQ is the angle sustained by the chord PQ at the center. This angle is sustained by chord PQ at center, and this angle PRQ is angle sustained by the chord at circle. We discuss a relationship between these two angles. angle PRQ will be half of angle POQ. To prove two equal chords of a circle sustain equal angle at the center. Here is two chords A, B and CD. Both chords are equal. We wish to prove that angle AOB is equal to angle COD. Then we take two triangle AOB and COD. Here OA is equal to OC. These are radius. OB is equal to OD. These are radius. And AB is equal to CD. These are equal chords. It is given. Now you can say that triangle AOB congruent to triangle COD, and this conclude that angle AOB is equal to angle OCD. This should be proof. This is proof of the theorem that equal chords of a circle sustain equal angles at the center. If the angles sustained by the chords of a circle at the center are equal, then the chords are equal. You can prove this theorem as converse of the theorem proved before. In this situation, you should also prove that given two triangles are congruent. Now, perpendicular from the center to a chord. Let there be a circle with O as center and let A be one of the chord. This is a circle whose center is O and AB is chord. When we draw perpendicular OM on chord, what happened? Now, when we join OA and OB, we will get two triangles AOM and BOM. Now in triangle AOM and BOM, we can prove that these two triangles are congruent. And after proving that these two triangles are congruent, we will see that this angle is equal to this angle. And this line is straight line and both angles are equal. That means both angles will be equal to 180 upon 2. That means 90 degree. And we conclude the theorem, this discussion that after this discussion we conclude that the perpendicular from the center of a circle to a chord bisect the chord and perpendicular on the chord. Now, the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. This theorem is same as opposite theorem. In both cases we should prove that triangles are congruent. Infinite number of circles can be drawn through one or 2 points. In case there are 3 collinear points, then circle can be drawn, but the third point will lie outside the circle. Let us take 3 points ABC which are not on the same line. Here it is clear that we can draw a circle with 3 points, but it is condition that 3 points will not be on the same line, because 2 points can lie on a circle in a straight line. Then you can say when we draw a line from here, only 2 points of line meets on the boundaries of the circle. That means if 3 points are on the same line, we can't draw a circle going through these 3 points. We can draw a circle if these points are not in straight line. Conclusion: O lies on the perpendicular bisector PQ of AB. We have OA is equal to AB. These are conclusions. Now, equal chords and their distances from the center. Equal chords are equal distance from the center of the circle. To prove it, out of these line segments, the perpendicular from P to Q named PM will be 3. equal cards and their distance from the center. First of all, we should see here that PM is shortest line. PM is shortest line. L2, L3, L1. When we are increasing this angle, line becomes away and away from the smallest distance. We conclude that the length of the perpendicular from a point to a line is the distance of the line from the point. Distance of any point from the line can be measured to draw a perpendicular on the line. Theorem 4. Equal chords of a circle or congruent circles are equidistant from the center. For this proof, we have draw two chords AB and CD and perpendicular OM and OF. When we join these two lines OB and OD, we get a triangle OMB and OND. We can prove these two triangles are congruent, and in this way we prove that LB is equal to ND, and by previous theorem AB is equal to CD. Chords equidistant from the center of a circle are equal in length. It is proved before that chords equidistant from the center of a circle are equal in the length. Angles subtended by an arc of a circle. The end points of a chord other than diameter of a circle cuts it into two arcs, one major and other minor. I have discussed before that a chord divides circle in two parts. When we are discussing about circle, boundary of the circle, there will be two chords. There will be two arcs. One is minor arc, second one is major arc. When we are discussing part of the circle, whole part of the circular region, there will be two sector, minor sector and major sector. Now, next slide. We conclude that congruent arcs are equal arcs of a circle such that equal angle at the center. We have proved it before that equal chords sustain equal angles at the center. Theorem 6. The angle sustained by an arc at the center is double the angle sustained by it at any point on the remaining part of the circle. The angle sustained by an arc at the center is double to the angle sustained by it at any point on the circle. You can see here, if figure is not clear here, see, there is circle APQ, APQ and APQ. There are three formats of the same circle. We should prove that angle POQ is double of PAQ, or angle PAQ half of angle PPQ. Here you can see that in triangle APO, POB is exterior angle. So angle PAO plus angle APO is equal to angle of POB. And angle APO is equal to PAO. So angle of PAO is equal to half of angle POB. In similar way, we can prove that angle OAQ is equal to half of angle BOQ. Adding these 2, we conclude that angle PAQ is equal to half of angle POD plus BOQ are equal to half of POQ. This is the proof of theorem that angle sustained by NR at center is double of the angle sustained by same R at any part of the circle. Angle is the same segment of a circle are equal. By using previous theorem, we can prove that angle in the same segment of a circles are equal. Suppose PQ is our R and is sustained two angle PAQ and PCQ on the circle. Now we can use previous theorem to prove this theorem. Angle PAQ is equal to half of POQ using theorem 6. Similar way में angle PCQ is equal to half of angle POQ. From 1 and 2, you can conclude that angle PAQ is equal to PCQ is equal to half of POQ. This is proof of the theorem. Angle in the same segment of a circles are equal. Theorem 8. If a line segment joining 2 points sustain equals angle at 2 other points lying on the same side of the line containing the line segment, the 4 points lies on a circle. That means they are concyclic. Concyclic. If a line segment joining 2 points sustains equal angles at 2 other points lying on the same side of the line containing the line segment, the 4 points lie on a circle, they are concyclic. You can here understand this with this watch. If this is the base, 2 points, and 1 point is here 3 and 1 point is at 9. When we are joining this 9 to this 2 and 3 to these 2 points, 2 angles form. One is 9, this, and this one is this, 3, this. If this angle with 9 and 3 are equal, these 4 points are known as concyclic. Now cyclic quadrilaterals. Properties of cyclic quadrilaterals. A quadrilateral ABCD is called cyclic if all the 4 vertices of its lie on the circle. Note it, A, B, C, D, all 4 points should be lies on the circle, circumference of the circle. If we observe these cyclic quadrilaterals, we will find that angle plus A plus angle C is equal to 180, angle P plus B plus angle D is equal to 180. That means sum of opposite angles of a quadrilateral is 180. Sum of opposite angles of a quadrilateral is 180. What we conclude is सबसे हमने क्या सीखा? We conclude that a circle is the collection of all points in a plane which are equidistant from a fixed point in the plane. Second one is equal chords of a circle are of congruent circles sustains equal angles at the center. If the angles sustained by 2 chords of a circle or congruent circles at the center are equal, the chords are equal. The perpendicular from the center of a circle to a chord bisect the chord. The line drawn through the center of a circle to bisect a chord is perpendicular on the chord. These are main points which we have discussed in the topic. Thank you.